Hello guys, my name is Daniel. I am the TA for Dr. Cho's Intro to Physics Vpython class, and he and I thought it would be a good idea to get some videos just doing some Vpython tutorials, since there isn't necessarily enough class time to cover all that in class. So this was going to be the first video I was going to make just as an introduction to Vpython and Python, and just kind of help you guys get a grasp of what it is. Vpython, if you guys are not aware, is an extension. It's what we call a package that's added to Python. So that a lot of the stuff what you're doing in this class is you're just going to be coding with Python, and then you're going to be utilizing some of the tools in Vpython. So the ability to create like those spheres and the boxes and create all these images, that's the Vpython stuff. All the coding behind that's really Python. So I wanted to do the first video just talking about Python, and then the second video to talk about Vpython, and then the third video we can finally talk about adding them together. So I just figured we would go ahead, and I have a couple of things covered here just to help you get started that I've made with some pre-run codes. All of the links to these codes are going to be in the description of this video if you're watching it on YouTube, so you should be able to find it pretty easily. So what I'm going to do right here is we're going to jump into the first thing, which I think everyone should know, which is just printing. Printing is very simple. Pretty much every language that you're going to code in will have some way of outputting words or numbers into what we call the command prompt. So for example, what I'm doing is I'm printing, and I'm printing the phrase "Hello World." This is typically what you do for your first program. You know, if you're ever trying to create a first program and something, you just create a "Hello World" to make sure you know everything's running fine, and it just prints things out into the command. So notice I have quotations around this. This is because the word "Hello World," if I just want to print out a sentence, I need to put it as what we call a string, which has quotations around it. So I can also just print out like a straight number. So I just want to print out the number 4. I can print out 4. Notice what happens though if I try putting in "Hello World" without the quotation marks. It gives me an error because it's expecting some kind of quotation mark to qualify that as a string. So I'm just going to go ahead and set that back to 4. And notice what I'm doing here. Whenever you see me removing these hashtag symbols, that's called something called commenting out. So basically, if I put a hashtag in front of it, everything that comes after the hashtag on that line is not going to be read by the computer. So this is useful if you want to have something and you want to, maybe remove it from your code, but not actually delete all the lines of code, because you might want to add it back later. You can comment it out. Also, it's called commenting because you can leave yourself just helpful notes about the code you're running. So that's kind of the idea of what you can do. You can also print variables. So notice like a is a variable. So I can say like a equals 10. And if I print a, instead of just the letter a, it's going to say 10. And then notice here, I made something fancy. So I created a string that is a equals. And then you can add the other value, the other variable, and it will print them together. So a equals, and then the value of a. Again, all of this will be there for you to play with. And then the last thing I kind of wanted to talk about, this is a fine point, and you may not need it for this class. But like I said, this is what we call a string. A string is just what we call a word. In this case, a here, a was 10. So I'm gonna zoom in here while we're at it. A is what we call an integer, right? So it's just a whole number. But notice I can create a value b that is not an integer. This is another kind of variable that we call a float or a double. It depends how many decimal places you're going out to. But basically I can have this value 9/8. So the computer is going to read that as 1.125. And so if I just print b, it's going to print 1.125. But I can change the type of variable that b is going to be. So I can cast that as an integer. This is called casting. So if I put in like int and then open parentheses, close parentheses, everything I put inside parentheses will be moved towards an integer. So since this has decimal points, the only way to make it an integer is to remove the decimal points. So it'll round this to 1, and it'll just print out 1. I can also cast this as a string. In some versions of Python, you can't add two things together like this up here without them being strings. But I'll just show you. So if I make b this, I'm going to print b as a float, as an integer, and as a string. So notice that this is the b that was a float. When I cast it as an integer, it went back to just being the number 1. And I cast it as a string. This actually is being read by the computer as something different, although it prints out the same as this 1.125 thing. So that's kind of what's all going on down here. Printing is basically, it's useful for several situations. Essentially, if you're ever just confused about what's going on in your code, sometimes it's useful to get the computer to print things out to you so you can see exactly what's going on. Like if you want to check if some condition winds up being true, which we'll talk about later, you will print out like the value of certain things and make sure you know what numbers are going on. Because once you start writing like big pieces of code, this can get kind of confusing. Let's go back to our folder. So the next thing I want to talk about is conditional statements. So this particular thing here. So I've kind of made a few things. This is another way of commenting in Python, by the way. If you put 3 single quotation marks one after another, then it will say everything between the 2 quotation marks should be commented out. So notice I have a pair here commenting out this guy, a pair here commenting out this guy, and then I'm going to add a line, a pair here commenting out this segment of code. So that's just something useful. And notice I can comment out the comment with a hashtag. So this is an example of when it's just convenient to use a hashtag to undo something in your code. I'm going to do the same thing we did before. Like I'm going to say a equal to some value 10. Now conditional statements are basically just a statement that checks whether or not something is true, and if that thing is true, do something. So particularly here, you always start these as if, so if, and then the condition. So this condition is anything that can evaluate to either be true or false in Python. We call these Booleans. It's another type of variable. You are not really going to need to know too much about that for this class, but just know that basically what's happening here is this is going to either be evaluated as true or false. And if it's true, it's going to do everything that is in these indented lines following the if statement. So particularly I have if a is less than 20. And so when it gets here, it should say like, oh, 10 is less than 20. So it should print out a is less than 20. So if I run the program, a is less than 20. And then notice that if I change this to 30 and I run this, nothing happens. It doesn't print anything out because it never got to that line of code. Let's get to this guy. So now what you can also do is you can tell the computer, if something is true, do this. And then if afterwards you add this phrase else and then another colon after else, it will do, this is what will happen if the code is not evaluated to be true. So basically if this condition is true, do this. If it's not true, do this. So else, do that. So for example, so it's pretty much the same thing. So in this case, I have if a is less than 10. So let me just make this 9. And you can see that it's saying like, oh, a is less than 10. But now I'm going to make this 11. So now a is no longer less than 10. And so what you would expect is it'll print a is not less than 10. And as you can see, a is not less than 10. So it's a pretty straightforward situation of just saying, do this thing if this one thing's true, do something else if something else is true. And the last thing with conditionals is there's one more phrase you can kind of get to, or elif. So in this situation, I have like a is 15, and then I'm going to check if a is less than 10. It's going to do that. And then if I do elif, this is only going to run this if statement if this if statement was not true. So basically, if this guy's not true, do this one. And it has another condition, and it's going to check that condition. And if that condition's not true, it will go on again. So you could have a string of these elifs for a bunch of different situations. You can have none of them, just like we had above. But for example, I'm gonna make a less than 10, just to show like, oh, a is less than 10. And here, a is less than 10. And now it's this segment will only execute if a is not less than 10, but a is less than 20, right? So if I just make this 11, a is between 10 and 20, right? So this is a very straightforward example, and I'm also going to just make this like 21, just so we have the other situation, a is greater than 20, right? Essentially, this is just giving you some more powerful tools so that you don't have to do things manually. So if you're writing a piece of code and you want to check if something, or you want to have, if this one situation is true, run this segment of code, or if another situation is true, run another segment of code. You could write two different scripts, two different pieces of code that will do things and then just only use one situation with one and only use another situation with the other. But it's way more useful to use these conditional statements. So this is a very powerful tool. But in this class, we're mostly going to be using this in what I'm covering in this next bit, which is in loops. So let me get to loops. And this is really the crux of what you guys are doing in this class. So loops are basically just a way of doing things over and over again in Python. So basically what's happening here is, let's say I want to do something several numbers of times. Then a loop will allow me to do pretty much the same thing over and over and over again until some condition winds up not being true. So I'm just going to kind of run through this. So I created some value called I, just because I'm going to use I in the conditional for this loop here. So I'm going to be checking if I is less than a number, so I need to have created it first. So how these loops work is you say while, all lowercase, and then your condition with a colon afterwards. And so in this case, it's going to say while I is less than 10. So the first time it gets here, it'll say is 0 less than 10. 0 is less than 10, so it will run all of the code indented under the loop. So it'll print out what I have here is I is equal to, and then the value of I, right? And then, so basically what we expect is if I is 0, 0 is less than 10, so it's going to say I is equal to 0. Then the next line is it's going to say I is equal to I plus 1. So this is going to add 1 to the value of I. And then when you get to the bottom of a loop, instead of just exiting the loop like a conditional does, it goes back to the top of the loop and it checks the condition again. And if the condition is still true, it will run the code more times, and it'll continually do this until eventually this condition stops being true. So, here I increased I from 0 to 1, and then I go back to the top, is 1 less than 10? Well, 1 is less than 10, so it's going to print I equals 1, and then it's going to increase I to 2. And as you can imagine, it'll do this for 2, 3, 4, 5, 6, 7, 8, 9. When I equals 10, 10 is no longer less than 10. 10 equals 10. So it will not execute this code, and it will exit, and it'll just do all the stuff afterwards. So I just having it print I am done afterwards. So if I run this code, you can immediately see it printed off I equals 0, and it went all the way down to I equals 9. And then after it did I equals 9, it just went down here and said I'm done. Right? So I want to make a big note about the most important thing to remember with these while loops is you want to have what we call an exit condition. So you want to have some situation where that the loop will stop running if like a condition is met. So in this case, that condition is, well, if I equals or is greater than 10, the loop's going to stop. So you need to make sure that inside your code, something is going to happen such that the loop can eventually stop. So, like here, I'm increasing the value of I. I'm going to add a rate to this. So rate is something added in Vpython that limits how fast a loop can run. So if I type in 1, it will do 1 iteration of the loop per second. If I do 2, it will do 2 iterations of the loop per second. So I'm going to do this so you can visually see how it's printing out. And I'm just going to print it out at 1. So basically, it's doing this 2 times per second. So when I remove that condition, basically I'm not changing the value of I. So notice that I is going to be 0, and it's going to remain 0 forever. And notice that, like you can see right here, this is getting smaller. The code is still running, and it's going to keep running forever because I is never going to be equal to or greater than 10. Because I is always going to be less than 10, this code will run forever. And that can create some problems, particularly if that happens to me inside CloseScript here. Usually I have to completely kill my web browser and start up from scratch because it will because my computer will just shut down. But keep in mind, if I have this I incrementing thing, it'll just go through the loop, increasing the value of I by 1. Rate is probably one of my favorite things they've added to Vpython. It seems so small, but for a learning tool, it's great because you can see how the loop is executing things in a step-by-step basis, and you can watch it happen in real time. So I think that if you guys are learning how to use loops, I would always recommend adding a rate step for the first bit if you're doing this in Vpython, just because this is going to help you so much with learning how the loop is going and seeing it operate in real time. So I highly recommend that. But yeah, so all that's good. I'm going to leave this program, and that's loops. And the last thing I want to talk about are lists. So lists are, particularly for this class, you will only need it for Physics 2. That's the first time we actually start using loops, but it's still pretty important. So as you can see, I made several examples here. So essentially, a list is just a collection of things in Python. So that those things can be strings. So I can have multiple strings. I can have numbers. You can see down here we're going to do integers. You could do floats, any kind of variable. You could even do, later on in Vpython, we're going to learn how to make like spheres and stuff, like these objects. You can even create a list of spheres and things. So it's pretty much anything you want in this collection. So what I've done is I'm going to kind of recreate our hello world. So I'm creating a list, and how you create a list is you set it equal to these open brackets and close brackets, and anything inside the brackets are elements of the list, particularly things separated by a comma. So this is the first element of the list, and then this is the second element of the list, and it's separated by commas. And as you can see, you can add as many elements as you want to a list. So, 1, 2, 3, 4 down here, A, B, C. In this case, I'm going to have hello world. So this is useful because it allows you to store information efficiently. And later on, I'm going to show you how to use this with loops. And that's where this gets really powerful. But first, what we're going to do is we're just going to show it printing what the list is, like as an object. And then if you want to get out an element of a list, you add the name that you have given that list, open bracket, close bracket, and then a number. And that number is going to represent the index of an element. So particular lists in Python always start at 0. So this confuses a lot of people. The first index of the list is not number 1. The first index is the 0. The second element of the list, that's going to be at index 1, and so on and so forth. So just be cautious of that, because you can get some kind of confusing things where you're starting at 1 and then you're not doing things for this first element. But yeah, so I'm going to go run this code, and what you can see is it printed out the list, hello world, and then I printed out the 0 index, hello, and then the 1 index world, right? So I've put those two together, and it just kind of prints those out. So now I kind of want to show you like the powerful thing you can do with these. As we get on. So one of the cool things you can do is you can automate adding things to a list. So like a list can get bigger as you go on. So if I have a list that's equal to these characters A, B, and C, I can print that list, but then I can also add an element to the list. So if you ever want to add anything, you just say the name of your list dot append, and then the thing inside these parentheses is going to be what you're adding, right? And so what you expect is I'm going to print the list as ABC. Then I'm going to add an element D to the list. So when I print it again, it should be ABCD. And as you can see, that's true. So this is before I added the D element, and this is after. And you can also do some cool things. This is going to be useful later for if you're adding a bunch of elements, you don't always know how long your list is going to be. So what you can do is you can have a list, you can print the length of the list by saying len, open parentheses, the name of the list that you're working with, close parentheses. So this element here is just the length of whatever that list is. And then what I'm going to do after that code is I'm going to add another element to it. I'm going to add a 5th element, and then I'm going to print the length again. So what I expect is the list has 4 elements, so it should print the number 4. And then I'm going to increase the elements by adding a 5th element, and it should print out 5. As you can see, it said the length of the list was 4. Then after I added something, the length of the list was 5. This will get useful later as we get into some of our simulations and stuff like that for Physics 2, because sometimes you're going to add an arbitrary number of elements to a list, and you want to make sure that you know how many elements are in it at any given point in time. So now let's comment out these quotations. So another thing you can do is, instead of just giving it like index 0, index 1, you can also give it negative indexes. And what a negative index does is it starts from the back and works its way backwards. So this is index -1, -2, -3, -4. So if I have a list 1, 2, 3, 4, and I print out the -1 index of that list, it should be printing out this last element here, 4. So if I run this, it just prints out the number 4. Exactly what we wanted. And then finally, I wanted to show you guys this running with a loop, because this is where lists really shine. Doing things by hand with lists, while they can be like a little more convenient, really, you could do all of this in one line of code. Where it gets useful is if you want to, let's say, add a bunch of things to a list. So for example, I have I equals 0. So I'm just creating some counting index for me to iterate through my loop. And I'm going to run this while I is less than or equal to 10. So it's going to start at 0 and go all the way up to 10. And then I have a list. So this is an empty list. There's nothing in here. But if I wanted, I could put things right here, or you can just have something empty and then you can add stuff to it later. So what I'm going to do is I'm going to add the value of I to the list. So at index, when I equals 0, it's going to add 0. Then I is going to increase by 1 until I equals 1. And then it's going to add 1 to the list, increase to 2, and we'll do this all the way up until I equals 10. Then what I'm doing afterwards is I'm just printing out the list so you can see, what this list is. But if I run this, just notice that it's created a list that has all these numbers in it for me. This is useful, particularly like this bit of code. There's something a little different than just like adding I to the list, but sometimes you want to do something where you have a list that has 10,000 elements. I've written pieces of code that have had 10,000 elements in a list before easily. And so you don't want to be writing by hand, add element 1, element 2, element 3. It's really convenient to have the computer automatically add these for you. So just as a note, that's really useful to do. Then lastly, I just kind of wanted to show you the very short kind of example code that utilizes all the things that we've learned in the video. So this is just going to be a program that automatically creates a list that has the Fibonacci sequence, right? So n is the number of elements I'm going to want in this list, right? So notice I'm using n in my condition here. I'm saying while I is less than n. So if I want 10 elements, I just set n equal to 10. If I want 20, I can set it equal to 20. If I want 200, I can set it equal to 200. Really anything like that. So I'm just picking how big I want the list to be, and I'm starting off my Fibonacci sequence. You always need the first two numbers, which are 0 and 1. If you guys aren't familiar, the Fibonacci sequence is just a sequence where you add the previous two elements of the list to get the next element of the list. So here 1 is equal to 0 plus 1, 2 equals 1 plus 1, 3 equals 1 plus 2, and so on and so forth. 34 equals 13 plus 21. So what I'm going to be doing here is I'm going to say like while I is less than n, so I'm going to do this n times, and I'm going to figure out what the next number in the list is. I'm going to call that new number, and it's going to be equal to the last element of the list plus the second to last element of the list, right? So at the start, it's going to be 0. This is going to be 1. This is going to be 0. So it's going to add those together to get 1, and then I'm going to add 1 to this list, right? And then I just increase I so that we're keeping track of how many times we've gone through the loop so that eventually I gets bigger. But if I just run this, notice that this is the first several elements of the Fibonacci sequence, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. This is even further past what you did before. So now if I go back to editing this program, like I can do this for an arbitrary number of times. So let's just do this 100 times, right? And you can see like the code is automatically doing this 100 times for me, which is great. The Fibonacci sequence gets really big really quickly. But yeah, so you can see like it just kind of runs the numbers for you. Everything's great. I can do this 3 times, right? And it's just adding 3 elements to the list after the 0 and 1. So this is just like a good example of, hey, like we're using loops and we're using our condition right here. we're using our lists and adding things to our list, and we're printing. Like these are all very valuable tools, and nothing I've done in this video other than using the rate is in Vpython. This is all in basic Python. So without you haven't actually learned anything about Vpython itself yet. But what we're going to do is in the next video, we're going to learn what are the tools that Vpython adds. And then finally, when we start doing some of the programs for the class, you can see us actually using these together. So you need to understand these tools so that you can know how to work with the objects and stuff that Vpython has to offer. But I hope that was informative, and I'll see you guys in the next one.